Hi guys, welcome to Nirmal's Code. So in this video we are going to see the problem on key for gigs. It's an index of an extra element. So initially in this problem they have given two sorted arrays, array 1 and array 2 of distinct elements. So what does the term distinct means? So distinct is nothing but both the arrays will have unique elements. So none of the elements will be get repetitive. So they have different elements and they are also unique. And they also mentioned that the first array has one element extra added in between. So in this example, array 1 is the first array, and in this array, the 9 is the element which has been added. But if we check in array 2, you can see the element 9 which has been present in second array. So we need to return the index of the extra element which has been added in the first array. So in this example, you can notice that 9 is the element which has been added in our first array and its index is 4. How it's they also mentioned that zero based indexing is followed. So initially you need to check from 2 as 0 to 0, 1, 2, 3, and at last when it comes into 9 it will be the fourth index. So that they have been returned in our problem. So okay, so before moving on to this problem, so you can also note that is there is any approach to solve this problem? Yeah, there are many approaches to solve this problem. It's not pretty harder problem compared to some other problems which have been seen in our previous videos. But if you see, there are four approaches to solve this problem. The first approach is binary search. So if you take binary search, its time complexity is log of n. It seems to be much more less time complexity compared to other algorithms or other approaches that we are going to see. But if we take linear search, even though linear search is also a good option to solve this problem, but if we use linear search, the worst complexity is big of n. So it will not be an suitable one for to solve this problem, but still it works. And next we are going to see about hashing. So hashing is nothing but based on the key, you are going to check whether the value is incremented or not. For example, if you take 2, 4, 6, 8, 9, 10, 12, and in this array we have 2, 4, 6, 8, 10, 12. And you can also check by whether to decrementing or incrementing the particular key value, and you can also tell that this particular value has not been incremented and that particular value will be returned in our problem. So that's what can able to use by using hashing. So that says brute force. So brute force is always not an good option for solving any kind of problems, but if you use brute force, you are going to check each and every element from array 1 or array 2 to whether that particular element is present or not. If you are going to use brute force, then its time complexity will be big of n square, which is greater than the expected time complexity. So always try to use the efficient approach to solve the problem so that your problem will get executed without giving any TLE or any runtime errors. So let me move on to the problem approach. Okay, so we all know about when you're trying to use binary search, the entire elements should be sorted. So they also mentioned the problem, the given arrays are in sorted manner. So surely we can use binary search or linear search, but better option is binary search. Okay. So first of all, in binary search, we try to compare by finding out the middle element with the rest of the elements, and we try to check whether the particular element is need or not, and we try to return that element or we try to return the particular index of the element. Okay. So first of all, I'm going to keep ln r for tracking the element. So L is equal to 0 and R is equal to 6. So this is what does L is equal to 0 and R is equal to 6 determine? So if you see here, array length is 7. Okay. So it is 0 based indexing is followed. So that's why initially I have mentioned L is equal to 0 and R is equal to 6. Okay. L is equal to 0 here and R is equal to 6 here. Okay, we need to find out the middle value. How we will try to find out the middle value? So we need to add L plus R divided by 2 equal to 6 by 2 equal to 3. 0 plus 6 divided by 2 equal to 3. So we'll get the middle value as 3. Okay. In third index, we have the value is 8. So 8 is the element which have been present in our third index. Okay, this is in our array 1. The same thing if you see in array 2, third index, we have the value 8. So it's something similar. They are equal. Even in array 1, the value is 8. In array 2, the value is 8. Then if the both the values are same, then we don't need to check the rest of the left elements which are present in the array. Okay. In left, surely we can able to say that the left elements are always same. So for that purpose, next we can move on to the right. Surely say that the elements which has been present at the right side of the array are not same. For example, here 2, 4, 6, 8, 9, 10. Okay. Sorry guys, I need to, in fourth index we have 10. And in fifth index, we have 12. I need to change it. I have not changed it. Actually, I'm sorry for that. Okay. If you see, the left side of the elements are same. We don't need to check the left side of the array elements. But you can say that the right side of the elements after the middle parts are not same. For example, if you see in fourth index, we have 9. But in here in fourth index, we have 10. So that's the reason we are going to check in the right side of the array. So now the L will move on to, in L we try to change it as m plus 1. So middle element is 3 and we are going to add 1 and we move on the L to the fourth index. So that's what happens in our second iteration. So now L will become 4 and we are not going to change the value of r. It's going to be in the same position as before. R is equal to 6. And when you are going to add 4 and 6 and you are going to divide by 2, you'll get it as 5. So that's what the middle elements of the next iteration. Now the middle element is 5 and in fifth index we have the value 10. It's in our first array. But if we see in our second array, in fifth index we have the value as 12. Still now it's not same. But if in the previous iteration they are same. So here the next iteration you can see 10 and 12 are not same. So in this case you need to decrement the value of the r by 1 by subtracting from the middle value. For example, here if you see r equal to m minus 1. Here the middle part is 5 and you are going to subtract it by 1. You are going to move that r to the left side. So when you are going to subtract it by 1, you will get the value as 4. So now L, M and R, everything will be in their same position. Okay, L is equal to 4, L is equal to 4, R is equal to 4, here R is equal to 4 and M is equal to 5. But now in the next iteration it have been changed to 4. For example, if you take L is equal to 4, okay, 4, R is equal to 4. I need to then have not changed here. Okay, now L plus R is 8 and when you divide 8 by 2 you will get it as 4. Okay, so now everything is in the same position and we are going to check up to when L is less than or equal to R. Even the L and R can be same, but R value should not be less than R, but it can be equal to L. Okay, so if you see here, in L is equal to 4, M is equal to 4, R is equal to 4. Now, in fourth index, we have the value 9, and in fourth index, we have the value 10. Still now, they are not same. So, we are going to decrement the value of R by 1. So, when you are going to decrement from the middle value, so middle index, you will get it as 3. So, now the next iteration, R value will become 3, L will become 4, and M will become 4. But in our condition, L is less than or equal to R. L can be less than or it can be equal to R, but it should not be less, but it should not be L should not be greater than R. So when you are decrementing the value of R, you will get it as 3 and L will not be get changed. It will be the same value like L is equal to 4. Okay. Now in the next iteration, it will check the part as 4 greater than 3. It's not the condition that we are going to use. So in that case, we will just terminate and we'll return the value as 4. So that's what this problem is going to do. And we'll see our coding part in our next session.